Hi everyone and welcome to the Wizard Engineer. In today's video, we're gonna get started learning TypeScript. We're gonna cover some basics required in order for you to get started learning Vue plus TypeScript that we're gonna cover in the next video. We're gonna learn what is TypeScript. We're gonna set up our dev environment so that we can get started coding in TS. We're gonna understand types in TypeScript. We're going to learn type annotation, what is a type annotation, and how to type our variables and functions. We're going to talk about interface and type aliases to create strongly typed objects. But also we're going to see the difference between interface versus type aliases. We're going to cover also type assertion. We're going to learn enums. We're going to learn option types, but also intersection types. So what is TypeScript? TypeScript, it is an object-oriented programming created and maintained by Microsoft. It is a superset of JavaScript, which means that any feature included in JavaScript, it is available as well in TypeScript. It supports all modern features, including in GS, like arrow functions, let, and const keywords. And when we create a TypeScript project, we need to pass it an extension of that of TS, and then we are going to compile our project down to JavaScript so that our code it can be read in the browser or and in the server. That's how it works, guys. I mean, when you have a TS project, you have to compile it down to JavaScript so that the browser can understand your code. And why should we use TypeScript? It allows us to create a robust application. We can detect typing errors when we are coding. And you can see we got a function double. It takes x as parameter. And I said that x should be a number. And this double function should return a number. And you can see when we pass our double function, we pass it a string. You can see TypeScript detects automatically that we just passing a string, and we are going to get an error at the compilation time. Now we need to install TypeScript and Node.js so that we can get started coding in TS. If you doesn't have Node.js installed on computer, we're gonna install it and as well as TypeScript. Let's get started. Alright guys, now we need to install TypeScript in order to get started learning it, and so we have to setting up our dev environments. You can go at Node.js.org website, and then you're gonna get into the download menu, and then you're going to see right here they suggest us to some Node.js version. You can see if you're on Windows, you're going to download a Windows version. If you're on Mac or Linux, you're going to pick a Node.js version that is related to your computer. And then right here, you have to make sure you pick a version which is greater than 17. And then right here, guys, we need to install TypeScript. If I get into my command prompt, and then if I type node.v, you're going to see this is my version, Node.js 18.18.0. And also we need to install TypeScript. Go at TypeScript.lang.org site, and then guys, you're going to get into the download menu, and then you're going to scroll a little bit at the TypeScript in your project section. And then you're going to see this command, npm install-g TypeScript, and then you're going to copy it within a command prompt. After you finish installing TypeScript, in order to check if TypeScript is well installed on your computer, you're going to type this command, tsc-v, and then you're going to see the version of TypeScript that you just installed on your computer. You can see right here, my version, it is 4.9. After that, we need to create a working folder. And then I'm gonna get into my desktop, cd desktop, and then I'm gonna create a folder. I'm gonna say make dir ts course, and then I'm gonna cd within this ts course folder, and then I'm gonna open my text editor. And then guys, we need to initialize a TypeScript project. And to initialize a TypeScript project, we need to type tsc-init -init. Yeah, like this. This is how we initialize a TS project, and then you're going to see within your working folder you have a TS config. It contains a bunch of property. I'm not explaining you all these property as we are progressing. Alright guys, we already learned how to set up a TS project by typing command prompt tsc-init, and we have created a tsconfig.json file, and it contains a bunch of properties that I'm gonna explain a little bit sooner. Now guys, before I go any further, I'd like to show you the topic that we're gonna explore throughout this video. We're gonna cover this topic right here. We're gonna get started with type annotation. And then if you want to go further in TypeScript, you need to expand your knowledge. You can go check it out, my TypeScript course. I cover some advanced topic in it. You can go check it out. You can see generic, condition types, type predicates, and so on. You're going to check it out, guys. The link, I'm going to put the link down in description so that you're going to expand your knowledge in TypeScript, guys. And right now, we're going to get started. And the first property that I'm gonna explain you about the tsconfig.json, it is going to be root dir. The root dir property, it is a property that we are going to uncomment and specify the working directory where we are going to store all our ts files. And then I'm gonna pass here source. It is going to be our working directory. And as you know, in previous video, I said that when we are just starting talking about TypeScript, I said that TypeScript, it is a compiled language. And also, we need to compile, we need to specify a folder where we are going to output compiled TS file, because when we are going to run TSC, it is going to compile TypeScript down to JavaScript. We need to specify a folder for that. We are going to look for another property out there where we are going to pass the name of the folder that is going to hold compiled TS files. We are going to pass here build. And then right here, I'm going to create the first one, the source, where we are going to put our TypeScript files. And then right here, I'm going to create first a file. And then I'm going to try to test if everything it is working pretty well as expected. I'm going to pass here main.ts. And then within the main.ts file, I'm going to create a variable. I'm going to say let's use name. I'm going to type semicolon, and then I'm going to specify the type. And then I'm going to pass here John Doe. And then in order to compile this file down to JavaScript, we are going to use a command provided by TypeScript. We are going to use tsc command. I'm going to open my terminal, and then I'm going to switch to command prompt, and then I'm going to type tsc, and then our project, it is going to be compiled down to JavaScript. You're going to notice that we just created another folder, which is build. The build folder, it contains JavaScript. You can see. And then you can see that it transpiled down the main.ts file down to JavaScript. And that's how we compile a TS project. We tap tsc, they're going to convert a TS file down to JavaScript. And also, if we get into the build folder, we have the possibility to run our file. If I get into again within the main.ts file and I type console.log username, and then I get into the working directory and I type tsc, and then it is going to be compiled down to JavaScript again. You can see right now we have the console.log within the main.js file, and then I'm gonna get into the build folder, and then I'm gonna type node. I'm going to use node in order to run our main.js file, node main.js, and then we can get John Doe within the console. You can see right here we got John Doe. And that's how we can compile a TypeScript project down to JavaScript so that the web browser can understand our code. Alright guys, now let's talk about type annotation. We are going to learn what is type annotation. So, what is type annotation? Type annotation, it is a process that allows to assign type to variables, array, and functions. Let's say right here we need to define a variable. Let's say actor name. And then we are going to use semicolon, and then we are going to specify the type, string. And also we can define another variable. We are going to say let's actor age, and then we are going to type it, semicolon, a number. We are going to say that the variable actor name, it is going to be a number. We are going to define another. It is going to be a boolean. Is actor alive? And then we are going to pass it a boolean. And then we have the possibility to assign it a value. Let's say right now we need to assign the actor name a number. And then you can see right here we are getting an error. TypeScript warns us that it is expecting a string instead of a number. That's why we are getting this error. You can see that TypeScript prevents us from typing errors. And in JavaScript, this works pretty well. But in TypeScript, it is not going to work unless we specify that the actor name it is going to be a type of string. And then right here, if I do this, I just enclose the 12 to quotation mark. You're going to see that the error disappear. But also can assign it John Smith, and then you can see the error disappear because John Smith it is a string. I can assign the actor age, I can assign it 12, but if I assign it a string, we are going to get an error. And that is type annotation. I can assign it a number is alive. I can assign it a boolean, false or true. If I try to assign it another value that is not true or false, we are going to get an error, a typing error. If I do this, try to convert false to string, we are getting an error. You can see right here, type string is not assignable to type boolean. Yeah. If we create a variable and we say that it is going to be a type of this, and we try to assign it a type which is not the type that we have specified, we are going to get an error. Also, we can create a constant right here, actor type. I'll say actor type, and then I'm not pass it. I can just specify the type string, and then I'm gonna say first level. I'm gonna pass it a random value, first level. And you can see that our actor type value it is a string. But if we pass here a number, we are going to get an error. And that is type annotation, guys. Now let's see how to type arrays. In TypeScript, in order to create an array, we use this. We use a const keyword or a let keyword, and then we are going to specify the name of the array. Use user ages, and then we are going to say we are going to create an array of numbers. We're going to pass here a number, and then double square brackets, and then we can just assign it a square bracket like this. We just define an array of ages, and then we have the possibility to pass in ages and so on. You can see it doesn't have any error. If we try to pass in the array a string, we are going to get an error. You can see right here we pass John, we are getting an error. If we remove John, the error disappear. We can try also to define an array of users, and then we are going to use string, double square bracket, and then we can assign it strings. Yeah, you can see right here I'm gonna pass here Isaac, but also we can use this syntax, const user roles, and then we're going to use the array class, and then we are going to pass it a string. And then we're going to say that we're going to create an array of roles, and roles are going to be type of string. I'm gonna pass here super user, and then right here we just created an array of strings. But also we can create an array of booleans. Let's say right here const actor actions, and then I'm gonna say right here it is going to be an array of boolean, and then I can pass in true or false. I can pass in only boolean values like this, true or false. This is how we can type an array in TypeScript. Yeah, just see, this is the process. We need to specify, we need to write first the name of the variable, colon, and then the type. But also we can type our functions. Right here, I'm gonna say function add numbers. It is going to make the sum of two numbers. I'm gonna pass here A, I'm gonna say it is going to be a number, and B, it is going to be a number, and then the return type should be a number. And then I'm gonna pass here A plus B, and then we can return a number. Yeah, you can see when we over our add numbers, the infers it TypeScript say that this add numbers function should return a number. And right here, when I'm going to call the add numbers function, I need to pass it two numbers. I can pass the first one 12 and the second one 3. But if I try to pass right here 3 as a string, we are going to get an error. But in JavaScript, you can't notice that you pass an error. You can see right here, we are getting ready to our file, which specifies that within our file we have an issue. And that is the benefit of using TypeScript. You can see right here, we should pass right here a number instead of a string. If we remove it, the error disappears. But also right here, if I do this, I try to return right here a string. Yeah, like this. And I've specified that the return type of this add numbers function, it is going to be a string. You can see right here. Yeah, it is a number. You can see we are getting an error because we just specify that the return type of our function, it is going to be a number. And if here I pass here a, you can see the error disappear because a, it is a number. And also we can create another function, pass here double, and then right here we can say a, can do this, a, it is going to be a number, and then we can just do a times 2, and here we can just pass here the return type, it is going to be a number. You can see right here, and when we are going to call our double function, I'm gonna say right here my double, yeah, like this, and then I'm pass here a number. But also we can define a function that is going to return an array. By doing this function, you get users, and then we are going to say that the parameter is going to take an array of users and pass here users, and then I'm pass it is going to be an array of string, and it is going to return an array of string, and pass here return users like this. And when I'm going to call our get users function, I need to pass it an array which contains string. Like this, I can pass here the username, number 1, number 2, and so on, like this. But if I'm trying to pass here, I try to pass here another primitive type, which is not an array of string, we are going to get an error. I'm pass here, let's say I'm pass here 12, we're getting an error, but in JavaScript, we are not going to get any error. In JavaScript, it is going to return 12, but right here, you can see we are getting an error, unless we are checking within the function that it is an array. But in TypeScript, we are coding an error immediately. And right here, I'm gonna pass here an array of string. You can see I'm pass here an array of numbers, and we're still getting an error. If I pass here an array of string, the error it is going to disappear. Alright guys, in this part we're going to understand tabs in TypeScript, and in previous video we just talked about tab annotation. We learned how to assign tab to primitive tabs, and right here you can see in this file understand tabs.ts. We're gonna get started with tab inference, and we already learned how to tap a variable. And when I copy, I'm gonna try to put my cursor over the actor name, you can see right here there's a pop-up, and this is what we call inference, tab inference. And you can see when I over the actor name, TypeScript infers it. TypeScript says that the actor name, it is a type of string. That's what we call tab inference. When I over again actor age, TypeScript infers it to be a number. I'm not getting to the understand tabs.ts. I'm gonna create another variable. Let's say employee name, and then I'm type it to be a string. And then when I'm going to over the employee name, TypeScript it is going to be infers it to be a string. But what if I don't specify the type, and then I let it like this? You can see when I'm going to over the employee name, TypeScript it is going to infer it to be a type of any. You can see right here, let's employee name and semicolon and any. the infers is a type of any. It is a type that can accept any JavaScript primitive types. We can assign to our employee name variable a number, a string, an array, an object, everything we want because it is of any type. And if I try to assign it an empty string, you're going to see that when we are going to over again the employee name, TypeScript it is going to infer it again to be a string. Even though we don't specify the type, you can see right here they infer it to be a string. Now let me remove first the value that we just assigned to the employee name, and then I'm gonna try to assign it. You can see the employee name, I can assign it a string, I can assign it an object, I can assign it an array. Every primitive types that exists in JavaScript can be assigned to employee name because it is of any type. Right here you can see. And I'm comment this, and then if I come again and assign it, it's an empty string. And then if I try again to assign it, let's say a number, we are going to get an error because right now the employee name, right now TypeScript infers to be a string. And you can see that's what we call type inference. Yeah, we're gonna move on. And what is literal type? Let's say right here, I'm gonna create another variable. Let's say employee gender. I'm gonna assign it a male. And when I'm going to over the employee gender variable, you can see they infers it to be a string. If we doesn't specify the type, they infers it to be a string. I can do even this. A string, no error, but if I pass here a number, we are going to get an error. Yeah, because we just assign it a string. But if I pass here 12 and I remove the type annotation, the TypeScript is going to infer it only to be a type of string or a type of number. And then right here, I'm going to pass here a string, and then I can just assign it a string male. And then right here, they infers it to be a string. And again, if I try to create the same variable with a const keyword, let's see what we're gonna get. I'm pass here employee gender, and then I'm gonna assign it. I'm gonna say it is going to be a male. I pass here male, male, and then you can see right here, if I do this and over the employee gender, they infers it to be a type of string. I can pass here, even here, female. It is the same, female, and they still infers it to be a string. But if I try to remove the type annotation, let's see what we're gonna get when we are going to put our cursor over the employee gender. They infers it to be female, and that's what we call literal type. It means they infers a variable to its value. And when we create a constant, a variable, and we doesn't specify we doesn't do type annotation to it, and then we just assign it a value, they're going to infer it to its value. If I pass here 12, let me pass here 12, you're going to see the infers employee gender to be 12. You can see right here. If I pass here a number, they're going to infer the employee gender to be a type of number. But if it doesn't do type annotation, they're going to infer it to be of its type. And that's what we call literal type, guys. We are going to create a function, and we are not going to specify the return type. I'm going to pass here function multiply, and then I'm pass here a and b is parameter, and then I'm pass here return a times b. And then if we over the multiply function, TypeScript infers it to return a number, even though it doesn't specify the return type. You can see right here, they infers our multiply function to return a number. But if I create another function, say hello, and then I'm gonna say return hello. And right here, when I'm going to infer say hello, when I'm going to over the say hello function, this infers it to return a type of a string. If I create another function, show message, and then right here, and then I do console.log hello, and then right here when I'm going to over the show message, they say that the return type, it is the type annotation added to our show message function, it is of a void type. A void type, I mean, it is a function that is not going to return any value. If I pass here, I add a void type to our function, and then if I do this, return hello, you're going to see we are getting an error because we just say that it is not going to return anything. This is what we call void. Yeah, void type. You can see, even though it doesn't specify the type, the return type, and you can see they infers it, they say that the return type of this function, it is a type of void. You can see. Now here we have the possibility again to create a function, but we are not going to specify, we are not going to type our arguments. You're going to see, you're going to say function multiply numbers, and then I'm passing a and b. I'm going to remove this time the type annotation to a parameter, and then I'm going to pass here return a times b. You're going to see, yeah, you can see when we over this a, they infers it to be a type of any. You can see right here, and they say that a, and they say that the multiply numbers function should return a number because we just add right here an operator. That's why they infers our function to return a number. And if I remove, let's say I remove this operator, the multiplication operator, they're going to infers our function to return any. And guys, if we call our multiply numbers function, you're going to see we can pass whatever we want because we say that the value of a, it is of any type. I can pass even here hello 12 and here hello, and then you can see. But here we are getting an error because it doesn't specify a return type. But if here we type the a to be of any type and b to be of any type, we can pass whatever type we want, like this, and we can do even this. Yeah, it is going to work. But at the compile time, we are not going to get an error, but at the runtime, we are going to get an error because we can't do 12 a string times an array. It is an error. It is going to throw an error at the runtime. We are going to learn how to prevent this any. It is dangerous because it is not sparing us from getting errors. We are going to learn how to protect us against errors. And that's all for this part, guys. I'd like only to understand types in TypeScript. We just cover what is type inference. We learn when we put our cursor over a variable, we can see its type. You can see right here when I over the employee name, we can see that they infers it to be a string. But if it doesn't specify, it doesn't assign it any value, they're going to infer it to be of any type, and we have the possibility to assign it every primitive type we want, a number, an array, an object. But also we talked about literal type. You can see right here when we create a variable with a const keywords, and it doesn't specify type to it, and we over this variable, it is going to be infers to its type, and that's what we call literal type. We talked about a function that where we doesn't create a function where we doesn't specify a return type, and you can see TypeScript detects automatically its return type. Say that it is going to be a number, and if we create a function, and also we create a function, say hello, and you can see we just return a string. TypeScript infers it to return a string, but if you pass here number 12, they're going to infer that say hello, it's going to return a number because we just return a number. But also if we doesn't we create a function show message and we doesn't return any value, they type it to be of a void type. It's a function that doesn't return anything. And we talked about also the any type. We learned that if we create a variable with any type, we can assign it to whatever type we want. And that's pretty much it for this part, guys. And I see you in the next part where we're gonna talk about array and tuple. I see you there. In this part, we're gonna talk about arrays and tuple. We're gonna learn what is a tuple and see the difference between a tuple and an array. In one of our previous parts, we talked about array. We learned how to assign type to an array. You can see right here we have created an array of user ages, and we just use semicolon and number to specify the type, and then we have assigned it a bunch of numbers. We have created an array of users. You can see right here we assign it John, Smith, and Isaac. And we have created also, we have learned also how to create an array of booleans. We have assigned it booleans value. And then guys, here we have another type of an array in TypeScript. That's what we call a tuple. A tuple, it is an array of a fixed size. Let's say right here, what we learned in previous video in our first parts. And then let's say here we have an array of ages. We can assign it. We are going to say it is going to be an array of numbers, and we have the possibility to assign it a wide range of items we want. We can go beyond thousands of items that we can assign within the ages array. But a tuple, it is an array of fixed size. As I said, you can see right here, we're going to say let actor actions. And then right here, I'm gonna pass here user actions, and then I'm gonna say it is going to be an array which is going to contain only two values. The first item, it is going to be a string, and the second item, it is going to be a string. Create and update. These are user actions. It is a tuple. If you try to add another action beyond this specified item, you're going to see we are going to get an error. If we add delete, we are getting an error. But if we add here, it is going to have a third item. It is going to be a string, no error. If we say the fourth item, it is going to be a number. And right here, we should pass here a number. If we pass a string, we are going to get an error. And that's what we call a tuple. A tuple, it is an array. We pass here the little definition, array of fixed size. That's what we call a tuple. You can see right here. If I pass here, modify the string to the number to string, the error disappear. Let's pass here another array. I can say right here, ages, I can convert it to be a tuple. Pass here, it is going to contain only one number. You can see, yeah, like this. And that's what we call a tuple. We just learned what is a tuple and the difference between an array. And that's pretty much it, guys, for this part. In the next part, we're going to learn how to create strongly typed objects by using Initialize. I see you there. Alright, guys, now in this part, we're going to talk about object typing. We're going to learn how to create a strongly typed object by harnessing the power of Initialize. Let's get started. In JavaScript, to create an object, we use the const keyword or the let keyword and then the name of the variable, and then we can assign it a curly braces. And we have the possibility to define, to pass in properly. We pass here the John Doe, John, the last name, we can assign it another property, Smith. We can assign it another object, a nested object. It is going to have two keys, email, and then you can pass here the telephone, yeah, like this. And if we over our user objects, you're going to notice that TypeScript infers it to be an object which contains the first name, it is a string, the last name, a string, but also it is a contact object which has two keys, email and telephone, and both are strings. And guys, if we need to add another object, we need to add another property, we have the possibility to do that. We can pass here address, can even pass here salary, salary 200, and so on. We can add more property we want to this object. We can add more property right here. More, we can go above 100 property, and so on. But how can we prevent this behavior? In previous video, we talked about tuple. We learned that a tuple is an array of fixed size, but also we can define a fixed size of an object by tapping it. Yeah, we are going to tap our object. You can see right here, I'm gonna say, instead of adding more property to our object, I'm gonna say that it is going to be a fixed object. I'm gonna add here semicolon and curly braces, and then I'm pass here first name. I'm gonna say our object, it is going to have one property, and it is going to be a type of string. And if I do that, you're going to notice that right now we are getting an error. They underlines that the last name. It says that we shouldn't have the last name within our object. I comment the last name. You can see the underline the contact. We shouldn't have the contact property within our object. And if I do that, the error, it is going to disappear. And we just created a fixed object, an object which has a fixed shape. Yeah, it should have only the first name. If I try to add another property, last name, and specify the type, you can see right now we are getting an error because we doesn't pass to our object another property. And if I uncomment the last name, the error disappear. And then we can pass the contact object, and then we are going to pass in to key. It is going to have the email, type of string, and the telephone. It's going to be a string, but also it's going to have the salary, type of number. We just define an object which has a fixed size. Yeah, I'm not uncomment this contact object and the salary, and we just created an object which has a fixed shape. You can see right here, our object has the first name, last name, and the contact and salary key within it. It is an object of a fixed size. And guys, if we continue with this process, we're going to end up with a code which is unclean. And to prevent that, we are going to harness the power of Initialize. You can see right here, if I need to add another property, address, let's say address, it is going to be an object. I'm going to pass here, it is going to be an object which is going to have, let's say, avenue string. Let's say it is going to have our user, it is going to have another key. Let's say user actions, it is going to be a tuple, and pass here string. I can pass even it is going, our user object is going to have another key. Let's say roles. Let's say user roles, and then let me pass here roles, and then I'm pass here is going to be an array, and so on. You can see that right now we are getting a code which is unclean. Let me specify first here the address. It is going to be have an avenue property, and I pass in an avenue, and also user actions. It is a tuple. We can have create and update, and roles array. We can have even admin, and so on. You can see right now, if we continue with this process, we are going to have a code which is unclean. And to have a code which is clean, we are going to harness the power of Initialize. I'm gonna remove this, and then I'm gonna use the Initialize keyword, and then I'm gonna pass the name of our Initialize. I'm gonna say user, and then I pass our object right here. And then I'm gonna use this Initialize to tap our object, and then I'm come over here and tap it with Initialize. You can see right now we just have a code which is clean. Yeah, this is an Initialize. We can use an Initialize to create a strongly tapped object. You can see right here. Yeah, our code it is clean. Instead of passing here directly the shape, we should use Initialize to have a code which is clean. We can also create another variable. I'm gonna say user inputs, And then I'm gonna say our user input, it is going to have two key. I'm pass here the interface our user inputs, and then I'm gonna say it is going to have the email string and the password string. And then I'm gonna tap our variable user input with an interface I user interface, and then I'm pass here user@gmail.com, and also I'm gonna pass here the password password. And we just created a user input which is tapped by an interface I user input. Yeah. But also we can use an interface to specify a parameter for a function or an array. We can use an interface to tap an array. Right now I'm gonna say this const user. I'm gonna pass here user data, and then I'm gonna say the user data is going to be an array. I'm gonna pass here iUser, and then curly braces to specify that is an array. You can see right here the iUser, it is a type. If I pass here string, it is a type, and then I can assign it an array. But also I can pass here the iUser, because the iUser interface, it is a type. And you can see when we over our user data, they infer it to be an array of iUser. I mean, when we are going to pass data to our user data array, we should pass it this kind of object, this one. You can see this is the iUser. If we pass this, we just pass it the first name, yeah, like this. You can pass it John, and we doesn't pass other keys, other property, last name, contact. So you're going to get an error. You can see right now you're getting an error because we said that the user data is going to be an array of iUser interface. And if I pass this object, the error disappear, and so on. Yeah, you can see that we just strongly tapped our array. It is an array of iUser. Yeah, you can see how you can tap an array using an interface. Yeah, you can see. You're going to practice, guys. And then, guys, if we can use even also interface to define parameter for a function. Let's say right here, I'm gonna copy this, and then I'm gonna move at the bottom, paste it, and then I'm gonna pass here function get user input, and then I'm gonna pass here input, and then I'm gonna tap the input with iUser input interface, and then I'm gonna say it is going to return this input. And then if we over our get user input, they infers it to return an object of iUser input. This is the return type. I can copy this and paste it right here, and it doesn't get any error. And we can just call our get user input, and we can pass it two key, email and password, like this. Yeah. And when we call our, and when we can even store this in a variable, let's say user inputs data, and then we can console it to the console, like this. User input data. Yeah. And let's try to compile our TS projects. I'm gonna open my terminal, and then I'm gonna switch to the command prompt and type tsc to compile our project down to JavaScript. And when we are going to get into the builds folder, you're going to see within the object typing dash interface.js, we doesn't have interfaces. They remove it, but we just have only JavaScript. But we use TypeScript to detect typing errors. And then I can get into the build folder and tap node. I'm gonna use node to display the data, to run our file object typing, and then we're going to get our objects. And now let us go back within the object typing interface. And you can see right now we just pass our get user input function. We just pass it an object of iUser interface. And if we try to pass it another property which doesn't exist, let's say username, we are going to get an error because the username doesn't exist within the user input interface. And that is the importance of using TS. If I try to pass here square brackets, I say that right here, it is going to take an array of user inputs, and our get user input function should return an array of user input. You can see right here, we are getting an error on the return. You should pass here this to remove the error. But also right here, you can see we are getting an error because we just passed to our get user input function an object. If we wrap it within an array, within square brackets, the error disappears. And that's pretty much it, guys, for this video. In the next video, we're gonna talk about type aliases and see the difference between type aliases versus interface. I see you there. Alright guys, in this part we're gonna talk about type aliases. We're gonna learn what is type aliases and how we can use it to create strongly typed objects like we did with interface. And then we're gonna see the difference, a little difference between type aliases and interfaces. We are not going to see a big difference because in this video we're gonna cover only the basics of TypeScript so that we are going to get started with Vue plus TypeScript. We are not going to learn a lot. And if you want to learn a lot, you can go check it out my TypeScript playlist where I cover most advanced features. If you need to expand your knowledge, you can go check it out, this playlist. I'm gonna put the link down in the description. And then guys, we're gonna move to the next point. We're gonna talk about extends keywords. We're gonna learn what is extends keywords and how to use it. We're gonna talk about intersection type, and finally we're gonna end up these parts by learning what is optional type. Now, what is a type aliases? A type aliases are type that we use to create a strongly typed object by using the type keyword in order to define the type, but also we can use them to define a type for a parameter of a function, and we can use it to specify a return type. Let's say here we need to create an input, a type, or a type. Let's say actor input type. This is a type. And then we're going to say this type aliases actor input type. It is going to have two key user. We're gonna say actor name. Actor name is going to be a string, and actor email, it is going to be a string too. And then we're going to create a function, and this function is going to take an input, create actor, and this input, it is a parameter that we're gonna type with actor input type. And then we're gonna say the return type, it is going to be a string. And then we are going to do return input, and then we are going to get access to the name, actor name. Actor name, it is a string. If we over the int first, it will be a string. And then right here you can see we just return a string. And then we can call our create actor function, and we need to pass it to property actor email and actor name. But also guys, we can assign a type alias a primitive type like this. Let's say right here I'm gonna say type user data, and then I'm gonna assign it an array. I'm gonna say a string user data. And then if we create a function, let's say we have a function get user data, and then right here we say that the data is going to be of type, it is going to take the user data type alias, and then if we type our parameter there with user data type, and then when we are going to call our get user data, we are going to pass it an array of a string. You can see we can create a type alias to define a type, but also we can assign it a primitive type. Let's say type user action, and then I can assign it, I'm gonna say it's going to be a boolean. You can see right here. But also we can assign it a union type. A union type, it is a type that is going to have a fixed set of values. Let's say right here, type say user status, and then I'm say right here it is going to have active. Let me pass here active, and inactive. You can see this is what we call a union type. But for an interface, we can't assign it a primitive type. You can see right here, we create a user data type alias. We assign it a primitive type. It is going to be an array, and we can assign it a boolean. But for an interface, we can't assign it a boolean type unless we open curly braces and then we can specify within it property. But with type alias, we can assign it a primitive type. You can see right here, we can say type user gender. We can assign it a primitive type, a string. And then if we create a function, and then we can type it with this user gender type alias. And this is the difference, guys. And then you can see right here, we can assign it to type union type. This is called union type, user status. And then you can see we assign it active and inactive. And when we are going to type let's say a variable or a parameter of a function with user status type, it is going to have only two values, active or inactive. Let's say right here, we need to create a constant, const user status. And then we type it with user status type. And then right here, when we try to assign it a value, you can see we got a little autocomplete. They say we can select only active or inactive. If we select active, the error disappears. If we pass it inactive, like this, it doesn't get any error. But if we pass it another value, let's say active with an S, yeah, you can see we are getting an error. And you can see the type actives is not assignable to type user status type. Yeah, you can see we are getting an error because we doesn't assign it active or inactive. Let's say right here we are going to create type user role type, and user role type is going to be admin. We're going to have admin. We're going to say admin, sub admin, and then we are going to have another row, super admin. Let's say we have 3 roles, and then we're going to create a function get user roles, and then we are going to pass it a role as parameter, and then we are going to type it with user role type. And then right here, guys, when we are going to call our function, it is going to return, I'm going to pass here a string. It is going to return a string because a role, it is going to be a string. And then right here, guys, when I'm going to call get user role, pass here get user role, and then once I tap, I try to assign it parameter. You can see we are getting a little autocomplete of union type. We are getting admin, sub admin. These are values that we should select. You can see right here we can select admin. Yeah, it doesn't get any error. We can select even super admin. Yeah, it doesn't get any error. But if we pass a value which does not exist within these 3 values that we have within our type, that we have assigned to our user role type, we are going to get an error. You can see right here, if I pass here dash dash dash, we are getting an error because this value, it is not part of these 3 values right here. And this is what we call union type. I've already put here a comment, union type. This is what we call union type. We can even do this and create another function. Let's create a variable. Let's user gender, and then I'm gonna say it's going to be a union type. It's going to be male or female, like this. And then when I'm going to try to assign user gender a value, let's say user gender, I'm trying to assign it a value. You can see every time I'm trying to assign a union type a value, they provide us a little autocomplete. You can see we should select female or male. Yeah, if I select female, no error. If I pass here male, there won't be any error. But if I pass a value which does not exist, we are going to get an error. And then you can see when we over the user gender, TypeScript infers it to be male or female. And that is the difference, guys, between the interface and type aliases. You can see we can use type aliases to create a strongly typed object. But also we can assign it primitive type. Yeah, you can see right here, I just assign the user data type, a string, user action, I can assign it a boolean, I can assign it a string, a number. But also I can use type aliases to create union type that we couldn't create with interface, and that is the difference, guys. Alright guys, now let's move to our next point, which is the extends keywords. I think we are familiar with the extends keyword. We already heard about it. We use the extends keyword in object-oriented paradigm when we want that a class A extends behavior or inherits behavior of another class. Let's say we have a class A and a class A can extend behavior of another class. And we are going to use this logic here with interface. And then here, guys, you're going to see, let's say right here we have an interface I employee, and the interface I employee has a name and email. And then we have another interface, let's say I interface I timestamp, and the interface I timestamp, it is going to have two property, created at and updated at. Updated at, it is going to be a string. Now we need to create a function that is going to create an employee. Say function creates employee, and this function, it is going to take an input of I employee, and then we can use this function to create an employee. When we're going to call our create employee, we can just assign it the name and the email in order to create an employee. And then we want to create also another function that is going to return an array of employees. Let's say we have here another interface. Let's say interface let's say I employee list, and then we are going to say it is going to have the name and email, but also it is going to have two fields that is going to be returned from our database. Let's say right now it doesn't have this interface, and you can see right here, guys, if we create a function, let's say function get employees, and this function, it is going to return an array. I'm going to do this, an array of I employee list. And then we are going to do this. Yeah, like this. You're going to return an array of I employee list. And then we're going to pass in the name, the email, and created at and updated at. Yeah, like this. And updated at. And there we go. And right now it doesn't have any error because we are returning our get employees function. It is returning an array of I employees. And you can see here, guys, you can see right now we have duplicates within the I employees. And right now we have the I employee interface. But how can we make that the I employee list extends the I employee, extends property of the I employee interface, and extends property of I timestamp interface? We are going to use the extends keyword. We are going to remove this, and then we are going to do this extends. We're going to do this extends. It is going to extend I employee. it's going to extend iEmployee, and then right here you can see we are getting an error because right now the iEmployee list has only two property, the name and email. And then right now you can see we are getting an error. Created it is underlined with a red color because it is not exist within the iEmployee list universe. And also we can extend or to another interface timestamp. We can do this. I can uncomment this, and then I can pass here this interface too, and it is going to disappear. Or I can try to copy these two inputs to property. I can paste it right there and remove this and do this. And right now we are getting a code which is clean. We doesn't have duplicate keys by using extend keywords. An interface can extend another interface. I think you get it, guys. It is simple. Yeah, I think you understand. It is simple. You're going to try to practice at your own. But with type aliases, we can't use interface. We are going to talk about intersection type. Yeah, for type aliases, we have intersection type. I'm going to do the same thing. Right here, we have iEmployees. Here, I'm going to create another type. I'm going to say I'm going to say agent type. And then I'm going to assign it the name. Let's say the name is going to be a string and email a string, but also our agent type is going to have a union type. I'm going to say male, I'm assigning and female. And right now here, guys, I can create a function that is going to create an agent. I'm going to pass here function create agent. I can pass it an input of agent type alias, and also we are going to create an agent. Now let's say we got another function that is going to return a list of agents. Let's say get agents, and then it is going to return an array of agents, and also it should return created at and updated at inputs. Let's say right here, guys, we need to return an array of this shape. Let me copy this. It is going to the get agent function. It is going to, we need that this array right here is going to be a type of it is this array. It is going to have the name, email, and gender right here. And pass here first the gender, and also it is going to have two field created at and updated at. But right now we are getting an error because within the agent type we doesn't have created at and updated at. And guys, we can do this. We can use the ampersand sign, this sign, and then we are going to do this. It is going to play a role of we just add another type to it. We can do this created at and updated at. Yeah, like this. We can see the error disappear. I mean, it is a way that we just add a type to a type aliases by using this ampersand sign. But we can do also even this. We can do type. I'm gonna remove this first, and then I'm do type. I'm gonna pass here timestamp type, and then I can assign it this, and then I put it above the agent type, and then I can create another type agent list, and then I'm gonna assign it the agent type alias, and also I'm gonna use the ampersand sign, and then I'm gonna pass it the timestamp type, and then right here I'm gonna pass here the timestamp type, and then we can see right here we are getting the agent list type. And then right here I can try to copy this and pass it to the get agents function. And you can see right now our function is returning an array of objects of agent list type. And if we over the agent list type, TypeScript infers it to be a type of agent type and timestamp type. I mean, we are going to have these 5 property: name, email, gender, and created it and updated it. These 5 properties. And that's what we call intersection type. Intersection type. Yeah, that's it. By using this sign by using this sign, guys, this ampersand sign. This is what we call intersection type. You have to put it in your head, intersection type. Now, guys, we need to move to another type. Let's say right here, option type. Let's say right here you need to create a user. Let's say you got an input. Let's say you need to define an input, the shape of the input that is going to be provided. Let's say the user say I user API data, and then here the user it is going to be a type. Yes, I'm gonna pass here user API data type, and then the user needs to provide the email, the password, let's say address. I must pass here to a string, and then when we are going to create a function, let's say function get, let me pass here function get user API data, and then we are going to pass it let's say the user a parameter, and then we just type it with the user API data type, and then right here, guys, we are going to return the user, and then when we over the get user API data function, they infers it to return a user API data type. And then when we are going to call the user API data type, we should provide the email, the password, and the address. You can see right here should provide it free property. If we comment the address, we are getting an error because it doesn't provide the address. But how can we make it optional? We are going to use this modifier. This is what we call a modifier, question mark right here. But if we remove the address, we are not going to get any error. It is a modifier that we just add by using the question mark. You can see right here, we just pass the email and password. But if I try to do this again, I say that the password property is going to be optional, I can remove it right here. But if I remove the modifier right here, and you can see right now, we need to provide the password property so that the error can disappear. Yeah, and this is the optional type. We have the possibility to make some property option in our object. Like here, we can say the name, it is going to be optional by adding this modifier before the property. Yeah, I think you get it, guy. You understand it. And then the next video, we're gonna get started with Vue plus TypeScript because we already covered almost the basics required to get started with Vue plus TypeScript. And if you want to expand your knowledge, you can go check it out, this playlist. Alright, guys, in this part, we're gonna talk about enums and assertion type. Here, I should talk only about assertion type, but notice that I've jumped the enums parts. You can see right here, we already covered all this stuff, option types, intersection types, but I've jumped the enums. Enums, we need to cover it, and we're gonna end up with assertion types. Now, what is enum? Enum, it is a type that is provided by TypeScript. We can use it to type a property. Let's say here you have a function that I have to check the user type so that the user can get access to the admin area. Let's say function check user type, and then this function, it is going to take a parameter. Let's say user type, and then you're going to say the user type, it is going to be a number, and then you're going to do this. If user type it is equal to 1, we are going to console that log can see, let's say can see dashboard page. We are going to add another condition. If user type it is equal to 2, we are going to say console.log can see user page, you can see user page, and so on. And you can see when we're going to call our function, check user type function, we are going to pass here 1. And let's say you was working on a project and you spent 3 weeks without touching to the code base. And then once you get back, and then you can't understand this pretty well, or if you want to add another person to your repository that is going to contribute to your project, and if you get into your code and see right here, you call this function somewhere like this, check user type, you pass here 1. The guy that you are working with cannot understand what you are doing unless you create enums. Enums are type that is going to allow us to add readability in our code. Let's say here you got an enum, we use the enum keyword, and then you're going to say user type, and then here you're going to pass in property. The first one, you're going to say super admin. I'm pass here super admin, and then I pass the value is going to be 1. And I create another property. I'm gonna say sub admin, and pass here admin, super admin, and then 2. I'm gonna pass another level user free, like this, free, and then I'm gonna add a colon, and then we are going to use this enum to type our user type parameter. Instead of passing here a number, I'm going to pass here the user type enum, like this. And then when I'm going to check, instead of passing here 1, because I have the possibility to pass even here 5, yeah, you can see right now we are getting an error because we already said that the value that should be assigned to our user type should be super admin or user. I mean, the value should be 1, 2, or 3. That's why we are getting an error. If we pass here 1, the error disappears. But our code, it is not clean at all. And to make our code clean, we are going to do this. We are going to do user type dot admin. That is a good way. We're going to do user type dot you're going to do user type dot admin or super admin, and pass here super admin, and that is guy. And here we are not going to pass a number. Let's say we need to pass to the check user type function, we need to pass here free. We need to pass here free. You're going to pass here user. Let's pass here user type.user, like this, instead of passing a number. If a person that you're working with see that, you can say, oh yeah, they are passing here user type of user, and you can see your function, it is readable. But also we can use also union types that we covered in previous video. We can use also union type. We can achieve the same thing. I'm not comment this. Let me comment this. All this stuff. Yeah, let me comment this. And then right here, guys, I'm gonna say type. I'm gonna use a union type user type. Yeah, like this, user type. And then I'm gonna assign it free value. The first one is going to be admin. Pass here admin. The second one, it is going to be a super admin, like this, super admin. And another one, it is going to be the user. Right here, I'm gonna pass the user, like this. And then I'm gonna create our function. I'm gonna use our function create user type. I'm gonna copy this function under here, under the user type alias, and then I'm going to use this user type. And right now you can see we are getting an error because we should remove this. And then when I'm going to try to pass here a value, you can see we have an autocomplete. We should pass admin or super admin, one of the value that we got within the user type. Yeah, super admin. All right, guys, this is our last point about this tutorial of TypeScript. This is our last point, but I also would like to underline that we just covered only basics of TypeScript, guys. TypeScript is vast. We just covered only basics. I would like to tell you to continue to learn because we just covered only basics. Now let's check it out, our last part. Now we already learned this. We already learned about type annotation. And we say that, let's say here we try to create a constant. We don't say agent's name. And then if we assign it value, let's say we're going to assign it Ben. And then when we over our agent's name variable, you're going to see that it infers it to its value Ben. And if we don't want that the agent's name variable to be inferred to Ben, we can add type annotation to it by using this. But also we can assert it. Assert it means cast. We can convert this type to another type by doing this. By doing this agent name, right now they infers it to Ben, and then I can use the as keywords to assert it to be a string like this. You can see right now I assert the agent's name to be a string. When I over agent, you can see right now agent, it is a type of string. If I create another variable, let's say agent's age, and then I assign it 12, when I over the agent's age variable, they infers it, TypeScript infers it to be 12. If I use the as keyword, I just cast it, I just assert it. Assert means convert it to another type. I just convert it to a number, and that's what we call assertion type. And then let's say we got an agent's input object right here, and then we just assign it an empty object. And then when we over the let agent's input, you can see the infers it to be an object. What if we try to add in some property? Let's say right here we need to do this agent's input dot name, and then we need to add the name into the agent input. We're gonna say Ben, and then we need to add also the email agent's input dot email Ben. We're gonna do ben@gmail.com, and then right now we are getting an error because Ben and email does not exist within the agent input object. You can see right now TypeScript infers it to be an empty object. But how can we convert this agent input to an object of name and email? We are going to use the as keywords. As, you're going to do as curly braces, and then we're going to pass name and then email like this, and we just cast it to an agent input of name and email by using as keyword. We just convert it to another type. And also we can create an array. Let me give you another example of an array. Let's say here we got an array, agent array, and then it is empty. And right now when we over the agent array, you can see right now it is an array of any type. It is an array that can be assigned any type. We can do this. Agents array, we can assign it 1, we can assign it a string, we can assign it a boolean, whatever JavaScript primitive type that we have. You can see right now we have the possibility to assign it everything, every primitive type. You can see right now it is of enter. But how can we convert it? But how can we cast it or assert it to an array of name and email? We are going to use again the as keyword like this, as array, and then we're going to pass in an object of name and email like this, and then we're going to comment this, and that's what we call type assertion. We just assert our agent array to an array of name and email. And right now when we try to push in to add items within the agent array, let's say we need to assign in values, we should pass only the name and the email. Otherwise it is going to throw an error. And that is the assertion types, guys. By using the as keyword, we can assert a type to another type. And that's pretty much it, guys, for this video. you just learn the basics of TypeScript. I invite you to go check it out, the whole playlist, so that you're going to expand your knowledge in TypeScript. And in the next video, we're going to talk about Vue plus TypeScript. I see you there.